Have you ever wondered about the mysteries of the universe? The vast expanse of space holds secrets that have captivated humanity for millennia. In this video, we're about to embark on a journey to explore 10 shocking physics facts that will completely change how you view the universe around us. Prepare to have your mind blown wide open. Imagine a place where gravity is so strong, so overwhelmingly powerful, that nothing, not even light, can escape its grasp. That, my friends, is a black hole. These cosmic abysses are born from the death throes of massive stars, collapsing in on themselves until they reach a point of infinite density. This point, known as a singularity, is where the laws of physics as we know them break down. Around a black hole lies an event horizon, a point of no return. Once you cross this boundary, there's no turning back. The gravitational pull is so intense that you'd be stretched out like spaghetti, a process scientists affectionately call spaghettification. But black holes aren't just cosmic vacuum cleaners. They play a crucial role in the evolution of galaxies, influencing the formation of stars and shaping the very fabric of space-time. According to Einstein's theory of general relativity, time slows down in the presence of strong gravity. Black holes are still shrouded in mystery, but with telescopes like the Event Horizon Telescope, we're finally able to peer into their shadowy depths. Now, let's dive into the strange and counterintuitive world of quantum mechanics, where things aren't always as they seem. Here, we encounter one of the most baffling phenomena in the universe: quantum entanglement. Imagine two particles linked together in such a way that they share the same fate, no matter how far apart they are. This connection is instantaneous, transcending the limitations of space and time. Think of it like this. You have two coins, one heads and one tails. You separate them, sending one to a friend across the country. The moment you look at your coin and see heads, you instantly know that your friend's coin must be tails. This is the essence of entanglement, a spooky connection that defies our classical understanding of the universe. Quantum entanglement could revolutionize fields like computing and communication, allowing for the development of ultra-fast quantum computers and unhackable communication networks. We often think of physics as something confined to textbooks and laboratories, but its impact on our daily lives is profound. Take, for instance, the Global Positioning System, or GPS, a technology we now take for granted. Did you know that GPS relies heavily on Einstein's groundbreaking theory of relativity? GPS satellites orbiting Earth are affected by time dilation, experiencing time slightly faster than we do on the surface. While the difference is minuscule, it's enough to throw off GPS calculations by several kilometers each day. To ensure accuracy, GPS satellites have to account for these relativistic effects, constantly adjusting their internal clocks to match our earthly timekeeping. So the next time you use your smartphone to navigate, remember that you have Einstein's genius to thank for it. Few experiments in the history of science have been as simple yet as profoundly impactful as the double-slit experiment. This deceptively straightforward setup revealed a fundamental truth about the nature of light and matter, that they can behave as both waves and particles. Imagine shining a beam of light through two narrow slits onto a screen behind them. You might expect to see two bright bands of light corresponding to the two slits. However, what you actually observe is a pattern of alternating bright and dark bands, an interference pattern, as if the light were a wave spreading out and interfering with itself. This wave-like behavior is even more perplexing when you consider that light is also made up of particles called photons. This dual nature of light and matter, known as wave-particle duality, is one of the cornerstones of quantum mechanics. It tells us that the subatomic world operates by rules that defy our everyday intuition. For centuries, astronomers have relied on light to observe the cosmos, but light is just one messenger in the universe's grand symphony. In 2015, scientists made a groundbreaking discovery, confirming the existence of gravitational waves, ripples in the fabric of space-time predicted by Einstein's theory of general relativity. These waves are generated by some of the most violent events in the universe, such as the collision of black holes or the explosion of supernovae. As these massive objects accelerate and interact, they create disturbances in space-time that propagate outward at the speed of light, like ripples spreading on a pond. Detecting these faint ripples was a monumental feat of engineering and collaboration, involving thousands of scientists around the world. Using laser interferometers, incredibly sensitive instruments capable of measuring minute changes in distance, they were able to detect the subtle stretching and squeezing of space-time caused by gravitational waves passing through Earth. This discovery opened up a new window into the universe, allowing us to hear cosmic events that were once invisible to us. Imagine a world where matter has an evil twin, a mirror image with the opposite charge but otherwise identical properties. That, my friends, is the realm of antimatter, one of the most fascinating and potentially powerful concepts in physics. For every particle of matter, there exists an antiparticle with the opposite charge. When matter and antimatter meet, they annihilate each other in a burst of pure energy, releasing a tremendous amount of energy in the process. While antimatter sounds like something straight out of science fiction, it's very real. It's created in particle accelerators and even naturally in some radioactive decays. In the medical field, positron emission tomography, or PET scans, use positrons to image the body and diagnose diseases. And in the future, antimatter could potentially be used as a powerful energy source, with the potential to power spacecraft to distant stars. We often think of empty space as truly empty, a void devoid of any matter or energy. However, the quantum world reveals a much stranger reality, that even empty space is teeming with quantum fluctuations, particles popping in and out of existence. And the Casimir effect provides a stunning demonstration of this bizarre phenomenon. Imagine two perfectly smooth metal plates placed very close together in a vacuum. You might expect nothing to happen, as there's nothing between them. But surprisingly, a mysterious force arises, pushing the plates together. This force, known as the Casimir force, is caused by the quantum fluctuations in the vacuum. The Casimir effect is a testament to the weirdness of the quantum world, where empty space is far from empty. One of the most mind-bending consequences of Einstein's theory of relativity is the idea of time dilation, the notion that time is not absolute, but rather relative to the observer's frame of reference. This means that time can actually slow down or speed up, depending on your relative motion or the gravitational field you're in. Imagine two identical clocks, one on Earth and one on a high-speed spaceship traveling close to the speed of light. According to relativity, time would pass slower for the clock on the spaceship relative to the clock on Earth. This isn't just a theoretical concept, it's been experimentally verified. Atomic clocks flown on airplanes have shown slight but measurable time differences compared to clocks on the ground. And GPS satellites, as we discussed earlier, have to account for time dilation to maintain accuracy. Time dilation challenges our everyday perception of time as a constant, inflexible entity. The subatomic world is a realm of paradox and mystery, where the classical rules of physics break down and particles can behave like waves and vice versa. This strange duality, known as particle-wave duality, is one of the cornerstones of quantum mechanics and has profound implications for our understanding of reality. We often think of light as a wave, spreading out like ripples on a pond. And indeed, light exhibits wave-like properties such as diffraction and interference. However, light also behaves as a stream of particles called photons, each carrying a discrete amount of energy. This duality is not limited to light. It extends to all particles, including electrons, protons, and even entire atoms. In the famous double-slit experiment, we saw how light passing through two slits creates an interference pattern, as if it were a wave. This fundamental uncertainty is at the heart of quantum mechanics and challenges our classical notions of a deterministic universe. In the vast expanse of the cosmos, temperatures can reach unimaginable extremes, from the searing heat of stellar cores to the frigid depths of interstellar space. But there's a theoretical limit to how cold things can get, a point where all motion ceases and atoms reach their lowest possible energy state. This point, my friends, is absolute zero, or 0 Kelvin, which translates to minus 273.15 degrees Celsius, or minus 459.67 degrees Fahrenheit. At absolute zero, the very concept of temperature breaks down. Heat is essentially the vibration and movement of atoms and molecules. As temperatures drop, these movements slow down. At absolute zero, all motion ceases, and matter reaches its lowest possible energy state. At these ultra-low temperatures, matter exhibits bizarre quantum properties, such as superfluidity, where liquids flow without any resistance, and superconductivity, where materials conduct electricity with zero resistance. So there you have it, 10 mind-blowing physics facts that reveal the wonders and mysteries of our universe. Which facts surprised you the most? Let us know in the comments below. And don't forget to like and subscribe for more awe-inspiring content from the world of science. Until then, keep looking up at the stars and never stop questioning the universe around us.